Hi, everybody. My name is Paxton. I'm excited to give a flash talk today titled Drivers and Management of Changing Sediment Regimes in California Rivers. I first wanted to take a moment to introduce myself and our growing lab group here at Bren. I'm a first-year PhD student working with Raphael Schmidt in environmental studies. Over there on the left are some of my background and training, some of the generous donors funding our research. Raphael is a first-year faculty member here at UCSB, so we're excited to get our lab group going here in Bren. So if there's an open application open for some postdocs and some future opportunities for research. So if anybody's interested in global hydrologic modeling or the water food energy nexus, please let me know. So one of the fundamental questions of my research here is like, how are some of the disturbances, and for the purpose of this talk, wildfire driving changes in sediment dynamics and the sediment regime in our rivers here in the state? Because when most people think about wildfire, they think about forests and they think about burnt hill slopes. But wildfire is actually one of the biggest drivers of sediment dynamics within our systems. So burnt hill slopes will introduce sediment into the river network, which gets propagated downstream through our very complicated river networks through the state, and then are ultimately deposited in natural sinks such as floodplains and river mouths, but also a lot of unnatural sinks such as water infrastructure intakes, potable water supply, those types of things. Some of the most recent data coming out by the Joint Economic Committee is showing that there's a huge hidden burden of wildfire after these fires are extinguished. So one of the first questions that come out of this is, how do we model these sediment pulses through the systems and try to manage how these downstream infrastructures risk hazards can be minimized? So we're going to begin. So my research approach here at Bren is going to be using a systems framework, which uses very high resolution spatial data like spurn severity, hydroclimatic forcing, geology inputs. We're going to run those inputs through some numerical modeling approaches, including some of these transport laws, physics equations. One of my big goals here is to ramp up to like the river network scale. So not intentionally just looking at single events like debris flows or mudslides. I'm really looking at the landscape scale, how these systems propagate this material through and downstream. And then with the goal of forecasting or better understanding some of the impacts to downstream resources. I'm currently conducting a global review of over 300 publications on this topic of wildfire interactions between wildfire and rivers. One of the biggest things we've been seeing so far is that there's a massive regional bias in these publications coming out of across the world. These are concentrated typically in North America, Australia, and a lot of places around the Mediterranean. But this is also creating a scientific gap in our understanding of where these observations are occurring. So a goal of mine is to use California rivers as a case study to develop numerical modeling and more process-based models to be able to improve my modeling skills, but also apply this around the world to places that are now experiencing larger, more severe, more frequent wildfires. So that's my goal here. I'm interested in expanding this through a numerical modeling approach, but hopefully this will be a fundamental question of mine, maybe for the first chapter or two. So thank you. And if anybody's interested in hydrology, river modeling, mechanics, free to hear. Interested in talking this. Thanks.
Thanks, Paxton. I think we have time for one question. Bruce?
So fascinating topic, and I can certainly see the value of being able to develop these kinds of predictions in terms of understanding what might happen. Have you thought about, or are you planning to think about how these types of predictions could actually be used by policymakers and land managers and river managers?
Yeah, I mean, I think we have a pretty good understanding so far of the empirical observations of how things are happening within California, for example, but a lot of these observations or these empirical, we're not able to translate our empirical observations to places around the world that don't have these wildfire signatures in them. So hopefully it's like just improving our understanding of how these things propagate through the system and ultimately the risk and the rate, how the sediment is moving towards downstream resources will help managers mitigate that risk.